Good morning / afternoon class. Today is Thursday, and today is the first official day of your STAR review. Okay, every one of you should be getting this blue STAR strategy booklet. Okay, and this is going to be your booklet for the next couple weeks up until STAR test for you to do problems in, for you to study in, for you to really kind of fill the gaps of where you're lacking or maybe where you're having issues in math class, because everything that will be on the STAR test, every concept that will be on the STAR test is in this booklet. There are problems in this booklet that will be very similar to the problems on your STAR test, so it's really, really important that you're able to master this booklet and understand the material in it so you can be successful on your STAR test. If you would, please make sure you write your name and the class period. You will not take these booklets home. Okay, you will give these booklets back to the substitute at the end of class, and that way we can keep them in class, we can use them in class, and once we finish all the problems in them, then I will allow you to take them home so you can study and you can look over them and get extra practice maybe with your older brother or sister, mom or dad, or whoever is there to help you. And this booklet, it kind of looks just like your STAR test really. It's got the graph paper in the first page, and then it's got your STAR reference material in the second page, so that's very convenient, so you can always refer to that and look at that. As you know, we use that a lot in this class. And then it's actually got some extra stuff, which is really neat. It's got a function roadmap, which you do also have a copy in your ISN. It's got an algebraic organizer. It has a calculator help sheet. Okay, and so it's got a lot of really neat, nifty things to help you review. And it also has a lot of great little anchor charts here with slope and y-intercept and with graphing and Pythagorean theorem and even transformations. It's got some great models and pictures here for you to look at. So really great material for you to study, for you to be able to take home after we finish all the problems in this booklet. And so if you would, we are going to start on page 33, and we're going to start with dilations. Okay, and I'm going to do one of these problems. We're going to take a look at the strategy, and kind of how this book really works is you'll have a reporting category, okay, and it'll say a topic, right? So this one, for example, this is page 33, problem number 7. It will say the topic, which in this case is dilations, and on the first problem, it'll just be the number. Okay, and then it will show you a strategy. So it will show you this strategy here and tell you kind of what you're supposed to do, or a good strategy or a good way to work the problem. Okay, and then if I turn to the next page, you'll see that I have 7a, and then I have 7b, 7c. Okay, and so all the dilations, notice how they all say dilations, all the dilations are number 7. Each problem is just lettered differently with either A, B, C, or D. Okay, and then for example, you'd see the next one, that's when we go to number 8, and it's a new category. So each number is its own category, and on the first problem and any category, once again, there is a strategy. So once again, this is a great booklet for you to utilize and for you to look at. And so I'm going to do problem number 7 for you. Okay, and then I'm going to go through the rest of them, but I'm not going to give you the answers on the rest of them. I'm going to give you the answer on number 7. I'm going to work the whole problem, give you some strategies. Okay, and then once again, you can look at the strategy. But then for the rest of them, I might go through them a little bit here, but I'm not going to give you the answer. I'm going to kind of lead you to it, and then we're going to make sure that you've mastered the concept by you showing me that when I get back on Monday that you were able to solve these problems. So I will be checking these booklets first thing Monday when we walk in the door, and first thing Monday we might continue transformations or we might move on to something new, just depending on how far we get. All right, so looking at number 7, once again, we're going to do this. I'm going to do this entire problem for you. Okay, and we're going to look at the strategies. So this problem says quadrilateral ABCD is dilated using the motion rule XY transforms to 2x, 2y, with the origin as the center of dilation to create quadrilateral A prime, B prime, C prime, D prime. All right, so the first thing I would do, okay, is I would look at the motion rule. And I would say, okay, my motion rule is going from xy to 2x, 2y. And so for me, I immediately know that that is an enlargement. Remember, with dilations, we have two types, enlargements and reductions. Okay, and I know this is an enlargement because my scale factor is greater than 1. Okay, and I'm going to write that here, scale factor is greater than 1, that is an enlargement. Okay? And if my scale factor is less than 1, okay, then I have a reduction. So for example, this right here is an example of an enlargement. Okay, and I'm just going to write enlargement. This right here would be an example of a reduction. Because notice this coefficient, this number, this coefficient that is next to x and y, okay, is less than 1. Okay, so if my scale factor is less than 1, it's a reduction. If my scale factor is greater than 1, it is an enlargement. Okay, so I know my shape. If it's an enlargement, I know my shape's going to get bigger. Okay, if it's a reduction, then my shape would get smaller. Okay, and so for here, the strategy says to make a table. Okay, and that's an excellent strategy, always a good strategy when you're doing transformations. Okay, and so if you make a table with the coordinates of the 4 vertices, they would look like this. So see how point A is going to be at -3. So I would start here at the origin, and I go 1, 2, 3, and that's -3. And then I go up +4, 1, 2, 3, 4. And that's how I get to point A. So you see that point A is -3, 4. And this is how we get all of these vertices. Okay, so for B we did 1, 3 over 1 and up 3. We did 3, -2, which is over 3 and down 2 to get to C. And then of course for D, we did -2, -5. Okay, and so we go -2, -5. Okay, and so that is exactly what they did, was they just made a table with all the coordinates. Step 2 says, make a new table, multiply each pair of coordinates by 2, the motion rule, to get the new coordinates. Okay, so basically all we did, okay, and all you're supposed to do with dilations, is we took all of these coordinates. So for example, I took A, okay, and it was -3, +4. Okay, this is my x, y, my x and y values. Okay, I know my x, y is going to change to 2x, 2y. Okay, just like it says right up here. xy to 2x, 2y, xy to 2xy. Okay, so the best thing to ask yourself is, well, how did this change to this? Well, it was multiplied by 2. So I'm going to do the same thing here. I'm going to multiply by 2. So I do -3 times 2 is -6. And 4 times 2 is 8. Okay, and so this new point is A prime. Hence, you see A prime down here at -6, 8. Same thing right here. It's exactly what I did. All I did was multiply. Okay, and dilations, that's all you do, is multiply. You don't add, you don't subtract, you don't divide, you multiply. Okay, same thing up here as if I had a reduction. Okay, if I had a reduction, okay, I would multiply by 1/2. Okay, dilations, we are multiplying. All right, so let's go ahead and find the rest of these points. So B was 1, 3. So if I multiply both of those by 2, then I would get 2, 6 for B prime. Okay, because 1 times 2 is 2, and 3 times 2 is 6. If we look at C, it is 3, -2. So if I do 3 times 2, that is 6. And -2 times 2 is -4. That is C prime. And then if I look at D, -2, -5. If I multiply both of those by 2, -2 times 2 is -4. And -5 times 2 is -10. And that gives me D prime. Okay, and as you can see, all of these points here that I figured out just by multiplying these points by 2 are all the points down here. Okay, and that's exactly what it says to do in the strategy. Okay, and it's always a great idea to do this, no matter what the problem is or what the problem's asking you. It's a great idea to do it, just so you can figure it out. And then it's an even better idea to graph it. Right, so I want everyone to graph it. We're going to go -6, 8. So I'm going to go -6, And then I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is A prime. Okay, I'm going to do 2 comma 6, so 2 comma 6. This is B prime. I'm going to do 6 negative 4, C prime. And I'm going to do negative 4, negative 10, that's down here, that's D prime. And now I'm going to connect my shape, and I'm going to make it look just like this shape, except it is now 2 times bigger. It is dilated by a scale factor of 2. And so as you can see, it is literally the same shape. It has just gotten twice as big because it is an enlargement. My shape got bigger. Okay? And so here it says, which of the following represents an ordered pair for a vertex of quadrilateral A prime, B prime, C prime, D prime? Well, all you have to do is match it. Was A prime negative 6 comma 4? No. A prime was negative 6, 8. Was B prime 1 comma 6? No. B prime was 2 comma 6. Was C prime 6 negative 4? Yeah, looks like it to me. 6 negative 4. Was D prime negative 10 negative 4? No, it was negative 4 negative 10. So in this case, C would be your answer. Moving on to 7A. Alright class, and so we're going to start working on problem 7A. 7A says triangle ABC is dilated using the motion rule xy to 1/2 x, 1/2 y, with the origin as the center of dilation to create triangle A prime, B prime, C prime. So once again, the first strategy I would look at is that I know this is a dilation. Okay. I also know that it is going to be a reduction, because once again my scale factor is less than 1. Okay? And if it's a reduction, that means that my shape is going to get smaller. Okay? So here it says, which of the following represents an ordered pair that is not a vertex? That is not a vertex. Okay, so I need to find all the vertices. That way I can see which one of these answer choices is not a vertice. Okay? And so once again, the strategy, I'm going to list my ordered pairs. Okay, so A is at 2 comma 4. B is at 2 comma 2. And C is at 5 comma 3. And so now I'm going to apply my motion rule and get A prime, B prime, and C prime. My motion rule is 1/2 x, 1/2 y. Okay, and so I'm going to multiply all of these numbers by 1/2. So I would do in my calculator 2 times 1 divided by 2. 2 times 1/2 is 1. And then I would do 4 times 1/2 is 2. Okay, and literally it's just like saying half of 2 is 1, half of 4 is 2. Okay, you're just multiplying your original coordinates by 1/2. So right here, half of 2 is 1, and half of 1 is 1, excuse me, and half of 2 is 1 again, and then half of 5 is 2.5, and half of 3 is 1.5. Okay, and so I see A prime, B prime, and C prime, and I'm going to look at these and I'm going to see which one of my answer choices is not a vertex. Okay, I will let you look at that. I'm not going to give you the answer because I pretty much have given you the answer, but I will let you look at that, and then when I get back on Monday, I'm going to take a look and see if you got the right answer. Okay. Moving on to 7B. 7B gives me a motion rule of 3x, 3y and it's a dilation, so I know I'm going to multiply, and I know that this is an enlargement because my scale factor is greater than 1. So with an enlargement, my shape's going to get bigger. Okay, and this one says which represents an ordered pair. So once again, I'm going to list those ordered pairs, and I'm going to find them. Okay, and once again, I'm actually going to let you do the rest of this one. So 7, I did all of it for you. 7A, I did most of it for you. 7B, I want you to do. Okay, and so what I'm going to do now is I'm going to give you about maybe 3 to 4 minutes. The substitute's going to pause the video. Okay, you're going to take 3 to 4 minutes. You're going to do it. Okay, and then we're going to move forward to 7C. Awesome. So you've had 5 minutes to do 7B. I will be checking on that one when I get back on Monday. Please also remember that this booklet will be for daily grades that will go on this 6 weeks. So please make sure that you are getting this done. 7C, triangle ABC was dilated with the origin as the center of dilation. Which rule best represents the dilation? So this one's interesting because on all the other ones, it gave us the motion rule, right? And so we could tell right away if it was an enlargement or a reduction. But now, we have to look at the graph. And most of you, from when we did this lesson, were really, really good at this. You noticed that the prime, the shape with the primes, was the new shape. And so here, the shape with the primes is going to be the bigger shape. And so if my original shape is the one without the primes, that means my shape got bigger, meaning that this is an enlargement. If my smaller shape was the one with the primes, okay, then it would be a reduction. But in this case, the shape with the primes is the larger shape, meaning that my shape started here and got bigger. Okay, and so this is an enlargement. So I know my scale factor is going to be greater than 1. Well, if I look at my answer choices, here is my scale factor greater than 1. I don't think so. It's 2/3. So that can't be my answer. Here my scale factor is greater than 1. So that definitely could be my answer. Okay, we don't know yet because we haven't looked at the rest, but that one looks good. Letter C, is this a dilation? I don't think so. It's got plus and minus. Dilations we multiply. This is a translation. So that's not even in the running. Same thing here. This is minus and plus. This is a translation. So simply by process of elimination and identifying that this is an enlargement, B is your answer. Now, if we actually look at it, let's look at the points. A is at -5, -2. B is at -4, +3. And C is at 2, 1. If I apply this motion rule of 1.5x, 1.5y, what that means is I'm taking these x and y values and I'm multiplying them by 1.5. And so when I do this, I get -5 times 1.5. That would give me -7.5. And then I get -2 times 1.5. And that gives me -3. Well, let's check out A prime. Is it right there at -7.5, -3? Well, let's look. A prime, if I look, I go over -7.5, which is right here, and then I go down 3. And that's exactly where A prime is. Okay, and that will happen every single time I do this. -4, 1 times 1.5, that gives me -6. 3 times 1.5, that gives me 4.5. If I look at -6, 4.5, Well, here's negative 6. Here's 4.5 going up. And that's exactly where B prime is. Okay, and same thing with C prime. 1.5 of 2 is 3. And 1.5 of 1 is 1.5. So I look at 3, 1.5, and that's where C prime is. Okay? Dilations are always multiplication. So anytime you have a problem with dilations and you see addition and subtraction, well, you know those aren't the right answer because dilations are only multiplication. Okay? You know that enlargements, your scale factor is greater than 1, and reductions, your scale factor is less than 1. So there are multiple strategies you can do. You can always do this. Always a great strategy. It's what we did on the last 3 problems. Okay? And once again, enlargements, your scale factor is greater than 1. Reductions, your scale factor is less than 1. So great ways to eliminate answers that do not make sense. Okay, so now we're on 7D. 7D says pentagon ABCD was dilated with the origin as the center of dilation to create pentagon A prime, B prime, C prime, D prime, E prime. Okay, and so once again, this doesn't give us our scale factor, but if we look here at the picture, we can see that the shape with the primes is the smaller shape, meaning that our original shape was the big one. So if our original shape was bigger and it got smaller, that means we have a reduction. Okay, and so it says which rule best represents the dilation that was applied to the pentagon. Okay, well, I know my reduction, my scale factor, is less than 1. Okay, so if I look here, once again, this is process of elimination. This one looks good because 0.5 is less than 1. Both of these are translations because they have addition and subtraction. And this would be an enlargement. And I know that by looking at the graph, this is a reduction because my shape starts out bigger and the primes are the smaller shape, so it gets smaller, meaning it's a reduction, meaning that A is the only possible answer choice. And if we tested out a point, I could look at point A, and I could say point A is at negative 6, 8. And if I apply my motion rule of 0.5x, 0.5y, well, half of negative 6 is negative 3, and half of 8 is 4. And so this would be A prime. Well, A prime is at negative 3, positive 4. Okay, and so literally all you're doing, no matter whether it's an enlargement or a reduction, is you're multiplying. Okay, and I can do this for every single point. What I want you to do, I know you've got your answer, I want you to do the rest of the points. You're going to take about 2 to 3 minutes, and you're going to do the rest of the points. You're going to do B, C, and D, and I want to see you apply the motion rule and match up the points and give me B prime, C prime, and D prime. That way on your STAR test, I know that you're able and capable of solving these problems.